Hello and welcome back, and welcome if you're new here. We are coding our chatbot using natural language preprocessing, which is a part of machine learning. So we have done quite a bit work here. We have talked about everything. We in from our first video we talked about libraries, what every library does, what is the function of every library. We imported our library. We imported our data. We made data frames out of it. We looked into our data. We have filled NaN values. Then we have done some basic operations here. We talked about text normalization. We looked into text normalization. We looked into word tokenization. We talked about word tokenization. We talked about POS tagging, which is part of speech tagging here. Then we talked about lemmatization. We made a text normalization function. In previous video we have done some count vectorizer function. We have done some count vectorizer function. We use our count vectorizer function, and we counted the occurrence of a particular word and the number of time it occurs in a given array. And we made our bag of words in previous video, and we talked about count vectorizer and bag of words in previous video. In this video we will do stopword removal, and before we jump into stopword removal code, I will try to make you understand what is stopword removal, and we will go here. So let's look into the definition first by Google. So Google says the idea is simple. It is removing the word that occurs commonly across all the documents in the corpus. And typically articles and pronouns are generally classified as top words. And if we go ahead and look into the images, we will get a clear picture that let's say trying to find some good. Okay, so here it is. We input tokenized data set. So we have created our tokens from our given sentence. We created a word tokenizer, and we have done our tokenization process in our previous video. I will like you to look into our previous video if you want to learn about this. We created our token, and what we can see here in stopword remover, we are removing the, of, the, and the, of, the, which if you look very closely, they doesn't provide any significant value to our given statement. If we remove these, our machine will understand word fine as if we don't remove it. So in stopword removal, we remove the articles or pronouns which we can remove, and it doesn't change the structure or the meaning of a sentence. So after removing, we will get function signature, include, name, function types, and parameter from it's from our word tokens which we made. The good example of stopword removal will be this. So this is from, I think, Geeks for Geeks. So they have given some sample text with stopword. Let's say Geeks for Geeks, a computer science portal for geeks. And if we remove stopwords from this sentence, the sentence would be Geeks for Geeks, computer science portal geek. So if you look that what we got after stopword removal, if machine goes through this, it will understand, okay, Geeks for Geeks, it is something related to computer science, it's something related to portals, and it is something related to geeks. So let's say we go to this next example. Can listening be exhausting? After removing our stopword from this example, we will get listening and exhausting. And if we go to the third one, I like reading, so I read. Like, reading, and read. So I hope you got a clear picture from this example from Geeks for Geeks. And now we will code our stopword removal process in our chatbot which we are coding. So we will go ahead, we have our bag of words, we actually counted the number of occurrence of our word, we have tokenized our sentence and everything, we have done all of that charades. Now we have to remove the stop word. So I will make a variable. Again, you can name your variable anything, but it should be not be special characters, should be not be, it should not be capital. You can use camel case if you want. Camel case is basically this, STO, then P, something like this. So I'm going with this, and I will say stopwords dot words, English, because we are using English here. English, we are specifying language here, and we will say print stop. So we are saying that from stopword, search for words in English. What is stopword here? Stopword is here. It's an function from nltk.corpus. We have talked about this in our first or second video. We have talked about every library in our first or second video. So we are actually invoking that here, and we are saying do this, and it should give us a list of stop words which are present there. So these are some stop words which are present in words English in stop word library. So we can remove this. So these are some stop words, just some are like I, me, my, myself, we, our, ours, ourselves, you, yours, and you get the picture of that. So let's test this with an a query example. Let's say I'm going to say question is equals to will you help me to understand the machine learning process? Will you help me to understand machine learning process? Let's go ahead and run it. So as you can see, nothing happens, and now we will check for stop words. I will say q, and I will make an empty array here, and I will say q. I will make an variable a, and I will say take questions which we have created above question and split it. What split will do? It will split the question, and we will say for I, we will iterate through it for I in a, for I in question, which we splitted this in a. If I is if I in stopword, if something like in this statement, if something is present in this stopword in the stopword array, we will say in stop, which is actually this for stopwords dot words, continue. I will say go ahead if it's there, else we will say q append. Append is basically joining q append I. If it's there, continue, like, and if it's not there, q, which is our this empty array, append I. If we found some if we didn't found something, append into this empty array. So we are basically essentially saying that if something is present in our stop word, continue, don't take it, and if something is there, take if something is not there, take that thing and put into our empty array here. So it will give us a list or an array of a word without these words in them. So we will say okay, b is equals to space dot join q, and we will say q. Now let's go ahead and run this. There is some syntax error. Okay, if should be here. Okay, continue is on the right place, and there indentation error, so be careful with that. So we will go ahead and we did this. Okay, and this one. Okay, now this is right because this is outside the if else block. Okay, now I will say question. Let's go lemma. We have talked about lemmatization, and we will normalize that text. Normalization. We will normalize that text which we applied to B. So what we will do, we will apply text normalization function on B, and if you got something from it, you can see that here we are making an array of a word which doesn't have these stop words in them. So this loop is essentially doing that. If something is there which is present in stop, so don't take it, else append into q, and then it is equals to b variable. So essentially the q is equals to b, and we are saying normalize the b array. So we are doing the normalization on b, and we will say question. Our bag of word is also there, so we will say question open question underscore bag of words, which is equals to cv. We will make a count vectorizer out of that. We will transform, and we will say question lemma okay to array. Okay, so what we have done here, we have created an empty array, and we said go through the a, which is our question dot split. We will split our question, this thing, and go through it. If something is present in stop, don't take it. If it's not there, append that thing into our empty array. So we will get something which doesn't have this, and we said that thing is equals to b. So we removed our stop words from this block. Then we go ahead and say text normalize. If there is something which need a normalization process, do that, which to be, which is essentially a q array, and then we will say okay, we got a normalized text. Then we will say okay, count the number of occurrence of a particular word and get that number into an array. That what we are doing here, we are creating a bag of word. So we'll go ahead and run this, and we will find about cosine similarity. So what is cosine similarity? Let's Google cosine similarity. Cosine similarity. Okay, so what is cosine similarity? Cosine similarity is basically a metric to measure how similar a text is between two documents, irrespective of their size, and irrespective of size of their documents. So this is how we represent. This is very fancy way to represent sine and cosine. So if you if you know that machine learning is all about matrix, statistics, and probability, and it's all about how close the data is. So cosine similarity is basically let's say a vector drawn to another data point from a data point, and that checks that how similar two data point between these two data point are. Like if some data point is A and some data point is B, we will draw a vector from here to there, and we will say how similar that is. So that is what it does to here. So here it is item 1, let's say A, item 2 B, and we will check the similarity, which is a dot b, which is a dot product, and a modulo b modulo. So it very loosely represents some formula. If you know what I'm talking from statistics, it loosely represents the correlation formula from statistics. If you are from the math field, you know that this formula is kind of looking like a correlation for a correlation, which is like a correlation formula, which is sigma root like power 2 minus I think whole to the power sigma f whole to the power something. So this represent that, and if you want to actually check it, correlation formula from stats, so it will be very similar to this correlation formula. So as you can see it is very similar to this formula, and this formula actually finds out the relation between two data points. So as I said, that machine learning is all about matrix, statistics, and probability. So that is what cosine similarity stands for. So now we will go ahead and we will code our cosine similarity part, and we will say cosine value which is equals to 1 minus pairwise distance, and it will take df underscore bag of word. It will take question beam bag of word bow, and it will use a matrix cosine matrix equals to cosine, and it will, and we want our cosine underscore value. So what I'm doing here, so this is our df bag of words, which is, if we go a little bit here, so this is our df bag of words. Okay, df bag of word is basically pd of data frame, which takes x, and what is our x? X is our count vectorizer 0101. Okay, and we are taking question bag of word. What is question bag of word? Here again you can see here count vectorizer is used, so it will also give 0101. Same, it will take these two values and it will plot them, and it will make an angle between them using cosine, and then it will find the similarity between these two data sets. So we will go there. Okay, pairwise distance is not defined, so if distances, I think. Okay, now you as you can see, we are getting the array here. Okay, I need to check again. To array, b to array. Okay, so yeah, let's like remove this and try to get something new, and let's check that this value differs there. Can you, let's say, will you help me and tell me about yourself? I'm doing this to check that we get different value or no for this different question on our cosine. So as you can see, we are getting the different value for our new question. So this actually gives us the similarity between our this question bag of words and what we got here. Here x, which is our df bag of words. And why we were getting 0 in everything? Because the question which we first asked was very similar to what we have created for our x. So this is what we do in our cosine similarity part. And let's check the question. So will you help me to tell me will you help me and tell me about yourself more? So it is giving us the correct question also. Okay, now what we can do is we can check the index of the highest value. Okay, like what is the index value of the highest value which we are getting. So I can say index underscore value, and we will say is equals to cos, which is again goes for cosine, arg argument, and max. Which argument is the maximum of cosine? Give me the index value, like put that value into index value, let's say 1, and let's say we go and say index value 1. Okay, cos not defined. Okay, we are getting some error here because name cos is not defined, so we have to create some cosine part of it. Okay, here it is. Okay, before doing this cos not defined thing, let's check for our text response that we are getting a response or not. So we will go ahead and say df, in bracket we will make a new column, let's say text response. We will do the cos thing because we have not defined our cos till now, so we have to first define it, and to define it let's first make some few changes. I will say loc, which stands for location 3, which is like df from DataFrame, the column text dot response locate 3, which is the location of what is at the location 3. So we get I can help you work smarter instead of harder, and as if we go above, we can see that at 3 in text dot response, let's say in 3 I can help you work smarter instead of harder. So we get there. Now we will go ahead and create tfidf. What is tfidf? So tfidf stands for term frequency inward document frequency, how many times a term occur in a document and how many times that document occur in our data frame. This is we gonna calculate tfidf. This is what tfidf stands for. We will say tfidf, and we will say is equals to, okay, tfidf f vectorizer. So we are invoking a function here, tfidf vectorizer here, which is term frequency inverse document frequency vectorizer. And as like if you're getting the gist of vectorizer, what vectorizer does, it will create an array or list of an array of 0 and 1 value. If there is a data, it will give us a 0. If there is a data, it will give us 1, and if there doesn't belong any data, it will give us 0. So what tfidf does, it will give us term frequency and how many times a document is there in our data frame, and how many times a term is in the document of our data frame. So I hope that is not confusing for you. So we will say tfidf, we are making a variable, and I will say is equals to tfidf, which is our this variable tfidf dot fit and transform, again tfidf dot fit transform. Fit and transform will fit that data and we will transform it. And what data we want to fit, we will say df, and the column we want to say is lemmatized, which is we want our this lemmatized text. We want our lemmatized text. So let's copy this lemmatized text from here to be sure that we are not making any grammatical mistakes. So we are saying that tfidf, we will get that lemmatized text column and do a tfidf fit and transform, which is vectorize it and store that thing into array, and you know what we will get from it. We will get a array, and if you want to look into this, you can say tfidf, and yes, we are getting this array. So what this is doing, it is actually calculating the number of frequency a term occurred in a document, first thing, and number of times that document occurs in our data frame. So data frame, document, term, document, data frame. There can be many number of times a term can occur in one document, and there can be n document in our data frame. So I think you got the bigger box, smaller box, smaller box. So I hope you understood that. So see, we are getting this calculation from there. Then I think I should stop this video here because it is getting overwhelming, and we will calculate our score for our tfidf, and we will code for unique words in our next video. So till then, be happy, spread peace, and if you want to help me, subscribe, ring the bell icon, like, comment, and if you don't like this video, dislike or comment. It's up to you, and take care of yourself. Bye.